So in this unit, we're going to be writing the equations in slope-intercept form. This entire chapter is about writing the line. So in the previous unit, we were given the equation. So for example, we were given y equals 2x minus 7, and we had to recognize which value was the slope, which value was the y-intercept, and to be able to graph from there. Well, this is kind of the flip. Our final product, we now want to be the equation, and that's what we were given the last time. So in order to write a line in slope-intercept form, we need two pieces of information over and over and over again. We need the slope as well as the y-intercept. So the first few problems are very straightforward. I give you the slope's value, I give you the y-intercept's value. You simply need to plug it in to y equals mx plus b, replacing your slope, replacing your y-intercept. So I insert negative 3/4 in for m and 7 in for b. So my final line is y equals negative 3/4 x plus 7. As we go through, we're given different pieces of information. So now I'm given a line. We go through the same entire process. I want two pieces of information always. I always want my slope. I always want my y-intercept. So looking at the data, I can find the y-intercept by looking at my y-axis. So I'm cutting through at 2. I can find my slope by counting my rise over my run. So up 4 over 1, up 4 over 1, up 4, right 1. All positive motions, up 4, right 1, up 4, right 1, up 4, right 1. So my rise over run is 4 over 1, which is just 4. So now that I have my slope and my y-intercept, I can insert that into the slope-intercept formula. So my final answer is y equals 4x plus 2. In our last example, we're given two coordinates. Same goal though. We want to find the slope. We want to find the y-intercept. I could graph these 2 points to kind of give me a better picture. So I have 0, negative 1, negative 3, positive 5. So what I notice right away is that I am given the y-intercept, which I should recognize the y-intercept because when x is 0, I get the y-intercept out. So I already know my b value is negative 1. We can find the slope by counting our rise over our run again. So I'm going up 1, 2, 3, 4, 5, 6 units, and backwards 1, 2, 3, so negative 3. So my rise over my run is 6 over negative 3, which is negative 2. So I have a slope of negative 2. However, we're going to come across 2 points that aren't going to be as nice to count on a coordinate plane. So it's important that we remember and we learn how to use the slope formula. So recall, slope is rise over run, which is our change in y over change of x. So I'm finding the change in y by subtracting the two y coordinates. I'm finding the change in x by subtracting the two x coordinates. These subscripts are just telling the difference between the first point and the second point. And it doesn't matter which one you label first, which one you label second, you'll still get the same answer. So I'm going to label the second coordinate, my y-intercept, x2, y2, and the first coordinate, as x1, y1. And then I just simply plug in. So my y2 value is -1. I'm subtracting y1, which is 5. My x2 value is 0. I'm subtracting x1, which is -3. So if I simplify that, -1 minus 5 is -6. 0 minus -3, we're really adding to get +3. So I maintain that slope of -2. Final answer, y equals -2x minus 1.